In any textbook or website I see where they write down the Green's theorem, I see this formula. And look how ugly this is. See, you have to think about a vector field PQ, and when you do a f dot dr around some boundary of a domain, domain D, boundary of the domain, and as you go around it, that this line integral is same as the double integral of this object here using the area integral. However, this is so ugly because it's not symmetric. It's really easy to forget whether P comes first, Q comes first, whether P is differentiated by X or Q is differentiated by Y or Q is by X. So I don't know why people write Green's theorem this way. Here's a much better way to write down the Green's theorem. Here, you see this one here is the determinant. So as you know, A, B, C, D determinant is AD minus BC, right? So if this hits Q, then this becomes partial of Q with respect to X, and when this hits P, that becomes partial of P with respect to Y, and you're subtracting just because of that. So indeed, this is same as our previous formula, but if you see this, how this is written, it's much better because it's perfectly symmetric. Nobody's gonna forget how to write this, and actually this is even better because this comes from the curl. This is really like the two-dimensional curl. Two-dimensional curl, because in 3 dimensions, curl of say PQR is defined as this determinant I, J, K, and then differentiation with respect to X and Y and Z, and then PQR, right? That's the definition of the curl. This is what we call the curl of PQR. And if you look at it, we see that this portion right here, which will be the component for K, is exactly what we're writing. So you can think of this as a two-dimensional curl. Okay. So if you learn Green's theorem this way, then once you learn this, after when you get to the Stokes theorem, it would be much more natural when you try to understand the Stokes theorem, because all this is really saying, that the left side is what we call the circulation of a vector field F, where F is P, Q, and this one here is the curl of F, and this equation, Green's theorem, is really saying that the curl F is the density of circulation, and this is explained in another video, so if you're interested in why this is true, please look at that one. Thank you.